protein can we absorb in one meal? Because I believe that there was some kind of limit to the amount of protein that the body can absorb in one go. And how long does it take to clear it?
Right. So in the past, research was like, oh, the most muscle protein synthesis you can get is from, 20, 30, 40 grams per meal. Not really true. As it turns out that if you eat just a huge bolus of protein, your small intestine slows way down. It's called an ileal break, and the intestine slows way down, and it keeps the protein in the lumen of the intestine much longer, so that all the aminos can get absorbed. And you will end up absorbing all of those aminos. So I have plenty of patients who just eat one meal a day, massive quantity of protein. I have patients who eat 200 grams of protein in one meal in a day, and none of that's coming out in their stool. They are eventually absorbing it all. They get this massive slowdown of the digestive process, and they're bleeding aminos into the circulation for 6, 8, 10 hours. Where typically, if you just eat a small bolus of protein, let's say you just drink a whey shake with 20 grams of protein in it, you're going to see a peak of aminos in the bloodstream at about 45 minutes. They're going to be mostly out of there in like 20, in about 2 hours. So whey is the fastest absorbing, fastest spiking, peak 45 minutes, leaving the bloodstream about 2 hours later. But then you eat like a steak. It's a way slower absorption, slows way down, ileal break, much slower bleed of aminos into the bloodstream. You get a smaller spike, but then a lot broader base of the area under the curve. And then if you try to do this massive one meal a day thing, it gets even more dramatic and more slowed down, and even more of a area under the curve. So you can honestly survive just fine on one meal a day. That's not optimal for building maximum muscle at all. And if you're a natural bodybuilder who's trying to get the very highest lean mass at the very lowest fat mass, you do actually want to eat at least 3 protein feedings a day, if not 4, and you actually want to spread them out over probably at least a 12-hour time frame. You're wanting to eat more frequent meals to make sure you have plenty of aminos in your bloodstream to make as much muscle as possible, or to inhibit muscle protein breakdown as much as possible. But then on the other hand, you've got like a lion who eats 1 gazelle a week, massive protein bolus, super slow down in the intestine. It's going to absorb all that every bit of that protein, use it all. You've got a boa constrictor doing the same thing once a month with a rabbit or something. And so like the idea that you can only get so much protein out of per meal is a joke, and humans would have been extinct by now. And you really don't have to worry about it that much. However, I don't think one meal a day is optimum. And I like, 2 or 3, or, I do 2 meals and a snack in an 8-hour window on a 16/8. But yeah, anyway.
I mean, not so much thinking about bodybuilders, but thinking about perhaps older people who are trying to maintain the muscle mass. So that would also make sense that we have like more than one meal a day.
Correct. Absolutely. So, and for older people, it gets kind of critical. So a 70-year-old male has to eat about twice as much protein as a 20-year-old male to get the same amount of muscle protein stimulus and anabolic stimulus. Older people get an anabolic resistance, where it takes more protein to build the same amount of muscle. It also takes more protein to inhibit muscle protein breakdown. So you have 2 things happening to muscle proteins. You've got muscle protein synthesis, which is stimulated by protein availability, eating protein, and resistance exercise, muscle tension. And then you've got muscle protein breakdown, which is also inhibited by protein availability, eating protein, amino acids in the bloodstream, and also inhibited by muscle tension and resistance exercise. So you're trying to build the most muscle you can and lose the least muscle possible. And you're really doing that with a protein, higher amounts, more frequent, more amino acid availability, and then also the stimulus from resistance exercise. So older people basically have to be doing resistance training and eating protein and prioritizing protein, and probably bookending their eating window with a large protein bolus at the beginning and a large protein bolus at the end. At a minimum, I would say 2 protein feedings in an 8-hour window beginning and end would be bare minimum, in my opinion. And even more or wider might be better. Like a 12-hour window with 3 protein feedings might be even better than that.
Do you see a sex difference between like men and women and their protein requirements?
Very little. There's very, very little difference between men and women. A few tiny differences. I mean, men tend to burn more protein with endurance exercise. So if a woman and a man are both doing an ultra marathon, for example, the man will burn a little bit more protein as an energy source compared to women. So they might have a little higher protein requirement from that. So I would say that's slightly skewing men into needing a tiny bit more protein. But for the most part, for your average reasonably active male and female, their protein, there's basically no practical differences. The women are eating a little bit less protein because they have smaller body sizes, and that's about it. So there's not a lot of difference. No.
Apart from like the protein energy density, what other differences are there between the different types of protein, like vegetable and red meat and white meat and fish?
Gotcha. So all of these proteins, whether they're plants or animals or anything else, are all just digested down into the same 20 amino acids, no matter what. So, protein is protein, but the percentages of these amino acids are different in plant versus animal protein. So, for example, plant protein has all of the amino acids in a spectrum and a percentage breakdown that you'd need to make a plant. And animal protein is a little bit more on the spectrum that you need to make an animal. So for, like the branch chain essential amino acids are a little bit different. Like, for example, the biggest amino acid stimulus of muscle protein synthesis is leucine. Leucine is the most anabolic muscle building signaling amino acid. And a high quality animal protein like whey or egg white, which is the gold standard, might have 12% leucine. But your very best plant protein like soy or something might have 6% leucine. So you can accomplish all the same things with plant protein, but you might have to eat more of it in order to have enough of all the aminos in the order that you need, or in the percentages that you need, if that makes sense. So you can basically, animal protein is a little bit better. You can do the same thing with plant protein, but you have to eat about 30% more to get the same effect. When it comes to plant protein, you're going to have to eat more. That's fine if you have a supplement. If you have a soy powder or something, you just eat more of it, not that big a deal. But it's not fine if you're trying to get that protein from a plant food source, a whole plant food source that has tons of carbs or tons of fiber. Like if you're trying to get that from broccoli, you're basically going to die of a bowel obstruction for the amount of fiber you have to try to consume. Or if I got all my protein from kidney beans, let's say, I would literally have to eat an extra 1,000 calories per day of carbohydrate just to get the same amount of protein. Not to mention the fact that I need a little bit more to get the same branch chains or leucine or anabolic effect. So, so if you're trying to accomplish it with plant protein, you're going to have to automatically eat more calories to get there. The spread of aminos isn't quite as good. And those are some of the problems with plant protein. But plant protein is okay. I mean, it's not bad. It's basically just as good, but you have to be aware of these limitations.